Hello students, in previous lectures we have discussed the bipolar junction transistor. Now we will discuss the unijunction transistor. So as the name implies unijunction, so there is a single junction and three terminals. Unijunction transistor. So we will see what is this unijunction transistor. So first we will discuss the construction of unijunction transistor. So as there is a single junction and three terminals, so this is N-type strip in which P-type region is formed. So this is a P-type region and this is a N-type strip, and there are three terminals. So the terminals drawn from these N-type strips are the base, that is base B1 and base B2. So this is base B1 and this is base B2, and the terminal which is drawn from the P-type terminal is emitter. So this is figure 1 which shows the construction of unijunction transistor. Construction of unijunction transistor, that is UJT. So we will see the next symbolic representation of this unijunction transistor. This is base B1, this is base B2, and this is emitter. So this figure shows the symbol of UJT. Symbol of UJT. So since this device has a single PN junction and three terminals, it is commonly called as unijunction transistor. With only a single PN junction and the device is formed, that is, in this device there is only single p-n junction and 3 terminals, and the 2 terminals are drawn from the base, that is base B1 and base B2. So this single junction and 3 terminal device is also called as the double base diode, because this is equivalent to diode. As in diode there is a 1 p region and 1 n region, and there is a single junction. So similarly in this device also there is a single p-n junction and 3 terminals, that is 2 terminals from the base, that is base B1 and base B2. So this device is called as double based diode. Also the next point one may take into consideration is that the emitter is heavily doped. This P region is heavily doped and this N region is lightly doped. So for this reason the resistance between the 2 base terminals is very high when emitter lead is open. So this is all about the description of construction of unijunction transistor. Now we will discuss the operation of unijunction transistor. Operation of UJT. So in order to discuss the operation of UJT, first we will see, that is, when no any bias is applied to the emitter terminal, and the second case in which a bias is applied to the emitter terminal. So this is the contact drawn from base, the 2 contacts, and this is contact drawn from the P region, that is emitter. So when this emitter terminal is open, that is, there is no voltage between base B1 and emitter, and this is a base B2, this is a base B1, and this is a emitter. And when the positive terminal of the battery is connected to base B2 and the negative terminal is connected to base B1 and potential is denoted as VBB. This is the first case when no voltage is applied between emitter and base B1. No voltage, that is emitter terminal is open with respect to this base B1, and we will discuss the next case. This is the case when voltage is applied between emitter terminal and base B1. So that here this emitter and base B1 is in forward bias. So this positive terminal of the battery is connected to the emitter terminal and negative terminal of the battery is connected to the base B1. This is the base B2. And as in previous case, here also the positive terminal is connected to base B2 and negative terminal of the battery is connected to base B1. And this is the potential which is VBB, denoted as VBB, and here the potential is denoted as VE. So this is the second case. So when there is no voltage is applied to the emitter junction and the potential or the voltage is applied between B1 to B2 is such that the positive terminal of the battery is connected to B2 and negative terminal is connected to B1, and as this is a N region and this is a P region, so in this case as N region is lightly doped and P region is heavily doped, and as the emitter junction or emitter terminal is open with respect to base B1, so due to application of this potential, the potential between base B1 and B2 is developed such that this base B2 is positive with respect to base B1. That is, base B1 is negative and base B2 is positive due to application of this VBB, that is potential which is applied between base B1 and B2, and this potential developed between these two or at this strip is denoted as V1. So in this case, as emitter junction is open, or there is as no voltage is applied between emitter and base, and only there is conduction of charge due to this application of voltage between base B1 and B2, the electrons will flow from base B2 to base B1. Then we will discuss the next case in which the emitter terminal is connected such that emitter terminal is this is a p-type region and this n-type strip. So the p-type the terminal drawn from this p-type semiconductor is connected to positive terminal of the battery, and that is B1 terminal is connected to negative terminal of the battery, and this voltage developed between the emitter terminal and base terminal is denoted as VE, and the current flowing is denoted as IE. Current flowing at this emitter terminal is denoted as IE, and the current flowing through this base terminal is denoted as IB. So there will be two cases when the VE, that is potential applied to the emitter terminal, when this VE is less than V1, that is potential developed at this base B1 and base B2. When this VE is less than V1, the PN junction remains in reverse biased. This PN junction remains in reverse bias. Because as this n-type strip is lightly doped and the potential developed at this bases B1 and bases B2, it will be here, it will be positive, here it will be negative, and this potential will be V1, and when this VE, that is applied voltage to the emitter terminal, is greater than this V1, then this PN junction will remain in reverse bias, while the second case in which VE is greater than V1, when this VE is greater than V1, there is a flow of electrons from base B2 to B1 in this direction, and due to which the PN junction becomes forward biased. PN junction remains in forward bias. Because there will be high positive potential to this which is given to this P region, and this, as this V1 is less than that of VE, this PN junction remains in forward bias. So this is all about the operation of unijunction transistor. In next lecture we will see the equivalent circuit of unijunction transistor and the characteristics of unijunction transistor. So with this I will stop here. Thank you.